So, have you ever wondered what's really going on in an examiner's head when they're looking at your paper? Well, that's exactly what we're going to do today. We're going to deconstruct a full 12-mark exam question to show you precisely how to think like the person with the red pen and lock in every single point. All right, so here's the plan. We're diving into question 4 from the AQA June 2023 higher tier chemistry paper. We're going to walk through it step by step, but we're not just hunting for the right answers. No, we're going to see them through an examiner's eyes, using the official mark scheme as our guide.
You know, this isn't really just one question, is it? It's more like a mini-test all on its own. For a whopping 12 marks, it manages to weave together energy changes, reaction profiles, covalent bonding, and even states of matter. Let's dig in and see how it all connects.
Okay, first things first, let's break down what they've given us. We've got the balanced equation, right? 1 mole of hydrogen plus 1 mole of chlorine gives us 2 moles of hydrogen chloride. And, super important, we have this table of bond energies. This is the raw data, the stuff we're going to work with.
So our first challenge is a bit of math and then an explanation. Let's really look at how the marks are given out here, because honestly, being precise is everything.
Question 4.1 is a multiple choice, asking you to pick the right expression for the overall energy change. Now you got to remember the golden rule here. It's all about the energy you put in to break bonds minus the energy you get out when new bonds form.
And there it is. For one easy mark, the mark scheme confirms this is the correct expression. We're taking the energy needed to break the bonds in the reactants, that's our HH and ClCl bonds, and then we subtract the energy that's released when those two brand new HCl bonds are made. Simple as that.
Okay, now for question 4.2. This one's worth 2 marks, and you have to explain why this reaction is exothermic. The mark scheme is super specific about this. Your first mark comes from saying that yes, energy is needed to break bonds, and energy is released when bonds form. You need that whole idea. The second mark, that's for saying the energy you get out is more than the energy you put in. You absolutely need both of those points.
Now this is actually really useful. The mark scheme isn't totally rigid, it gives you options. You don't have to use that exact wording we just saw. You could just straight up compare the numbers, or even just say that the overall energy change is negative. It goes to show there's more than one way to get to the right answer and back those marks.
All right, time for the artsy part of the question. Finishing off the reaction profile diagram for this exothermic reaction. This is worth a full 3 marks, so believe me, every line and every label counts.
So this is what you start with. They've given you the energy level for the reactants and that first little hump for the activation energy. But yeah, there are 3 pretty important things missing to complete the picture.
And here's how you get those 3 marks. Check it out. First, you get a mark just for drawing the product's energy level below the reactants. That's what shows it's exothermic. Second, you have to label the activation energy with an arrow going from the reactant line all the way to the peak. And finally, that third mark is for labeling the overall energy change, the difference between where you started and where you finished.
Okay, so the question switches gears now, moving from energy changes over to covalent bonding. We need to draw a dot and cross diagram for a hydrogen chloride molecule. This is a classic 2-mark challenge.
So how do you get these 2 marks? It's pretty straightforward. The first mark is for showing that one shared pair of electrons between the hydrogen and the chlorine. The second mark is for correctly showing the 6 non-bonded electrons sitting on the outer shell of that chlorine atom. And notice, it's cool whether you draw the shells or not, as long as all those electrons are clearly there.
And finally, we get to the big one, the long-form explanation comparing methane and polyethylene. This beast is worth 4 marks, and it's crying out for a really well-structured point-by-point comparative answer.
The question gives us the structures, and I mean the visual difference is just huge, right? Methane is this tiny, simple little thing. Polyethylene is this massive long-chain polymer. And that fundamental difference in size, that is the entire key to unlocking all 4 of these marks. To nail all 4 marks, you've got to build a complete chain of logic. Let's just use polyethylene as our example. Point 1. Its molecules are much larger than methane's. Point 2. Because they're bigger, they have stronger intermolecular forces. Those are the forces between the molecules. Point 3. Therefore, you need a lot more energy to overcome these forces. And point 4, what's the result? It has a higher melting point, which makes it a solid at room temperature. Each one of those steps is a mark in the back.
Now, stop for a second, because this is a huge warning pulled straight from the mark scheme. This is such a common mistake. When you change state, like melting or boiling, you are only overcoming the weak forces between molecules, the intermolecular forces. You are not breaking the strong covalent bonds inside the molecules. If you mention breaking covalent bonds, you will lose marks, even if the rest of your answer is absolutely perfect.
So after tearing this question apart and looking at its mark scheme, what have we actually learned? What's the big picture takeaway for absolutely smashing your exam?
Just think about it. This one question tested 5 core chemistry skills, from doing the math to writing clear explanations. It just goes to show how interconnected all these topics are. But more than that, it proves that using the precise scientific language that examiners are literally trained to look for is the absolute key to success.
You see, it's not just about knowing the chemistry, it's about understanding the game and how you're being marked. By using the mark scheme as your practice guide, by focusing on building those clear, logical arguments we've talked about today, you can walk into any exam and face any question with confidence. So really, what's stopping you from mastering the next one?